Okay, so in this video, let's talk about another fascinating thing about photochemistry, which is the excimer formation. Now, we have done several lessons about the photochemistry. Uh, let's look at this excimer formation. So, I will take a quick example, which is pyrene, right? Pyrene molecule. So, I will denote it as Py. Now, if we consider a normal photochemical process, right? I hope you know now what the basics of this photochemistry, the excitation process, then the emission process, right? Uh, if you have no idea, like if you are new to this particular video series, I highly recommend you to go back to our previous videos. I will put a link here. Now, when we consider this pyrene, okay, here we have the pyrene molecule. We can give photons to it and excite them. Now this pyrene molecule is excited, right? Then this pyrene molecule, this excited pyrene molecule will emit its excited state, like it will emit energy to get back into the ground state. Now here we have the pyrene in the ground state. This is the ground state. Now when this process happens, it will release energy. Now this process, this is the normal process which we would have observed in the pyrene of photochemistry, right? So we call this as monomer emission, right? You will understand why we specifically say this is a monomer emission, like why we specifically name this particular uh, process regarding the pyrene molecule. Now if we plot a diagram, right? So now what I'm going to do is I'm going to change the pyrene concentration. I'm going to use a very low pyrene concentration and plot the emission diagram like this. This is the emission against the wavelength. I will get this yellow diagram at the low concentration, right? This lambda 1 high peak gives in the low concentration, right? Now if I increase my concentration, if I increase my pyrene concentration, we will observe a fascinating thing, which is this lambda 2. Now at the high concentrations, right, at high pyrene concentrations, you will not see this lambda 1 peak, you will not see this yellow peak, you will only see this blue color peak. Okay, this is the most interesting thing. Now at low concentration, you will only see this yellow color peak, not the blue color one, only this one at the low concentrations. But when you increase the pyrene concentration, you will see only this blue color. Like you will see that this yellow colored peak, this one, right? This yellow colored peak will slowly shifted back into the lambda 2, this blue color one. Okay. Now when we increase the concentration, this deviation would happen. Now let's see, like, why do we observe such phenomena, right? Now what happens is this pyrene molecule is uh, there will be they will be forming a complex called a excimer. Now what is this excimer? Now in the excimer, okay, so excimer, it happens like this. Now when we have the pyrene molecules, it get excited in the contact with the photons. So here we have the excited pyrene molecules. Okay, now when the excimer formation happens, right, these excited pyrene molecules, okay, this will form weak bonds with other pyrene molecules. So this particular excited pyrene molecule will create a weak bond with another pyrene molecule. Now you know from the basic chemistry, like when we form a bond, when something form a bonds, like okay, so when something is form a bond, it gets stabilized. So the bond formation means this complex is getting stabilized. Now the complex we have, we denote it as this, like this we call as a excimer, right? This is stabilized, right? If I draw the energy diagram, if I draw the energy diagram, here we have the pyrene molecule, here we have the excited pyrene molecule. Now when the excited pyrene molecules form weak bonds with another pyrene molecule in order to form the excimer, it will get stabilized like this. This is the excimer. Now you can see this is stabilized, right? So this is the energy. Compared to the individual excited pyrene molecule, our excimer complex has lower energy, but still it has higher energy than the normal ground state pyrene molecule. But compared to this one, the excited pyrene molecule, our excimer complex is relatively stable. Now when this stabilization happens, now when the relaxation, I mean the emission happens, from the energy is removed from the excited state to the ground state. Okay, in the normal case, from the pyrene molecule, this excited state, this is the energy transfer from excited pyrene molecule to the ground state pyrene molecule. So let's denote the energy difference as delta E1. Now in the case of excimer, right, in the case of excimer, this is the energy difference. Our emitted photon is coming from this state to this ground state. So let's denote the energy difference as delta E2. Now what's the relation between the delta E2 and delta E1? Delta E1 is bigger than the delta E2, right? Delta E1 is bigger than the delta E2. Now these two energy values, these are the one which are denoted in these two specific scenarios. As you can see, lambda 2, which means in higher lambda values, if you remember from the basic energy equation, E equals hc over lambda. Higher the energy means lower the lambda value. So this delta E1, which is the higher energy, is corresponding to the lower lambda value. So this one here, this is the high energy emission, and this is the low energy emission, right? This is the low energy emission. Now why the low concentration we have high energy emission? It's because at low concentration, okay, we have less number of pyrene molecules in the system. So this bond formation between two pyrene molecules is less possible compared to the higher concentration situation, because in higher concentrations we have lot of pyrene molecules there, so there's a higher possibility to connect with each other. So these pyrene molecules can create bonds in higher probability because there are so many pyrene molecules in the system. But in lower concentration, we don't have such number of molecules, so it's really hard to form bonds between two molecules. That's why in low concentration, right, in low concentration, this excimer complex won't be formed. So only this emission will happen, which means the high energy difference. So relative to the high energy difference, we will observe the lower lambda value, which means this yellow color graph. Now when we increase the concentrations, what will happen is more pyrene molecules will be added into the system. So there's the possibility to form the bonds between two molecules and get stabilized, which means the excimer formation. Now when the excimer formation happens, our energy difference is lowered. Now due to that, we have higher lambda valued emission peak. So in this case, at higher concentration, we have this blue color graph. So this is the explanation for this particular scenario. Like this is what happens in the excimer formation. So you need to know about this graph. Like you need to be able to explain this graph if question asks. And there's another small thing, which is exciplex formation. Which is the same thing just like the excimer. Now in the excimer case, in our previous case, you will remember that our bond is formed between the excited pyrene molecule and a pyrene molecule. Now in this case, let's say we have A molecule, which is the excited one, and it will form a bond with the X molecule. So the two molecules are different. This is Exciplex. This is Excimer. Same concept, same theory, but only difference is the types of molecule. In Xplex, we have different type of molecules. So I hope you get the idea about this Xplex and Excimer formation. We will continue our discussion about the photochemistry in our next video series.